Okay, everybody, this is section 10.5, probability using permutations and combinations. We want to recall what a permutation and what a combination are, and the notation. So if you're not familiar with this, you should not be completing section 10.5 right now. You should be reviewing, if I recall, 10.3. So, what is a permutation? A permutation is when you are selecting distinct items from a list and you are placing them in order. For example, I have 3 people and I need to select first, second, and third place. I have 10 people. I have to select first, second, third, fourth, fifth place. So again, you are selecting different items from a list of different things and you're placing them in order. A combination is when you need only to select distinct items. For example, if I'm selecting from a list of 10 people and I need to select 4 finalists, then it doesn't matter when the person's selected. That's a combination. That's different from saying first, second, third, and fourth place. So you need to recall what a permutation is and a combination, and also the notation. Now, let's consider the following. I need to select 3 cars and 4 trucks from a selection consisting of 10 cars and 15 trucks. So, since I only need to select these items, it doesn't appear there's any particular order. There's not first, second, and third. Nothing indicating there's order. This is a combination, but it's a collection of 2 combinations, because if I'm selecting 3 cars, I need to select the 3 cars from 10. I need to select the 4 trucks from 15, and we know it's multiplication, so combination 3 pick 10, 10 pick 3, combination 15 pick 4. You can do your math. If you do your math, you get 120 times 1,365, and I will let you finish that up. I will not be completing the algebra portion. This is not 092, 09, whatever. I'm going to let you do the final math, okay? That way we can save time on the video. The next one. I need to select 7 vehicles from a selection consisting of 10 cars and 15 trucks. So once again, I'm selecting items. There appears to be no order, and therefore this is a combination. Now, I didn't say I needed 3 cars, 4 trucks. I didn't say anything about they had to be so many cars, so many trucks. So when I'm selecting, I'm picking directly from 25 vehicles, 7 vehicles, and 25 pick 7 when it's a combination is 480,700. So once again, you do the math. You can confirm this. Moving on to the next one. I have a list of names: Bob, Alice, Sally, Joe, Mark, Kate, Jamon, and I need to select first through 4th place in a competition. Notice when I'm selecting now, when I pick you, I'm saying something different. You're first, you're second, you're third, you're fourth. This is a permutation. There is order. Well, in this permutation, I am choosing from 1, 2, 3, 4, 5, 6, 7 people, 4 people. So this is a permutation of 7 pick 4, which is 840. Moving on. Reading this one. You should be stopping the video, right? I think I've said that enough, all right? But yeah, you should be stopping the video and working the problems, right? I have my list of names here. I need to order the 4 men, followed by ordering of the 3 women. So in other words, I'm going to order the men. So this is a permutation of 4 pick 4. I need to order the women. That's a permutation of 3, pick 3. So I'm picking everybody, but I'm going to put the men in order. Then I'm going to follow this by an ordering of the 3 women. So order your men, then order the women, then do your math, and you will see that you got 24 times 3, 2, 6. 24 times 6, and again, you do the math. All right, moving on to the next screen. A couple of more counting problems here to review. These are a little bit more complicated, so you really kind of need to understand the counting routine, right? From a list of the names we have, again, we have our 4 men and our 3 women, and I need to select 6 of them where Sally is first and Kate is last. So I have some conditions here. Sally needs to be first and Kate needs to be last. Well, in the middle, since I need 6 people, I need to pick 4 people from the remaining 5 people, right? We've already picked Sally, she has to be first. We've picked Kate, she has to be last. So in the middle, the remaining 4 people have to be coming from the 5, right? And that's a combination because, again, I just need to select them. It doesn't say there's any particular order. The only order we required was Sally goes first and Kate goes last. So who cares what's happening in the middle? That's a combination of 5 pick 4. If I did that right, that should come out to be 5. So the answer to this one is 5. Moving on. Read this problem. Stop the video. I'm working it out. I have my list of names. I need to order all of the names. So I need to order all of the names, but Bob and Alice need to be selected before the other 2. So here's what's going on here. Bob and Alice are going to go here. The remaining 5 people are going to go here. Now, for Bob and Alice, that's a permutation of 2 pick 2. Because again, I have 2 people to pick from. I need to pick both of them. They have to go first, so here they are, they're going first. For the remaining people, again, we're ordering. There are 5 people remaining, and I have to pick out 5. So that's a permutation of 5 pick 5. So permutation of 2 pick 2 is 2. Permutation of 5 pick 5 should be 120. So I'll do the math for you here, 240. Okay, so you have to be careful. Sometimes we have more than just permutations and combinations. It could be combinations of stuff, right? Counting problems can be complex. You got to kind of think of the process, what you have to do, lay it out. Okay, here's our next problem. You need to read it. This one now involves probability. We have reviewed combination permutation problems, permutations selecting from a list. There's order, different things, right? Combinations selecting from a list, different things, no order. Okay, you read the problem. We want to know the probability, so we're talking probability, that she picks 3 brown and 2 red worms, right? In this experiment. All right, well, she's going to pick 3 brown and 2 red. Remember the definition of probability. We need to know how many ways she can pick 3 brown. We need to know how many ways she can pick 2 red. We need to know how many ways we can pick 5 worms, right? That's the definition of probability. The number of ways things can happen. Well, how many ways can we pick 3 brown worms? Well, that's a combination. We're picking from 4, 3. how many ways can we pick 3 red worms? Well, that's a combination. We're picking from the 5 red worms, 2. I think I said 3, but whatever. 2 red worms, right? In the denominator, we just need 5 worms. Well, we need to pick the 5 worms from what? The 9 worms in total. So, once again, probability is a counting problem in general. We need to ask how many ways we can pick 3 brown worms. They have to come from the 4. We need to know how many ways we can pick 2 red worms. They have to come from the 5. We need to know how many ways we can pick 5 worms in general from the 9 worms. You do the math. Here's the answer. C of 4 picked 3, 5 picked 2, 9 picked 5. There was no indication of any particular order here. She's just picking worms to go fishing with, right? So you do the math. Okay, we have 10 people taking part in a raffle. Prize winners are going to be selected randomly from 10 people. And we want to calculate the following probabilities. For event A, we have 3 prize winners, which are Omer, Elsie, and Jim. And it doesn't matter what particular order they're being selected. So the order of selection does not matter. Apparently for event A, we are considering all the prizes being identical. So how many ways can we pick Omer, Elsa, and Jim? One way. Pick them, because again, there's no order. So it doesn't matter who got picked. If we need the 3 picked, there's only one way to do it. Pick them. The denominator is how many ways can we pick 3 people from the 10. And again, there's no order here. So that's a combination of 10 pick 3. Show yourself that is 120. So the probability of event A is 1 over 120. Considering event B now, we now have an order to our prize selection, right? Kiara is the first prize winner, Sue is second, and Ann is third. Well, again, in event B, there's only one way that we can choose Kiara first, Sue second, and Ann third. So once again, the numerator is just 1. But we're here in event B, we are making the assumption that there are differences in the prizes. So this is no longer a combination, but a permutation of 10 pick 3. That's what the denominators are going to be in this scenario. And that would be 720. This is a tricky problem here. Okay? In event A, we're assuming no order. In event B, we are assuming order. And that's the difference. But if you think about it, again, we have to pick Omer, Elsie, and Jim. There's only one way to do it. We have to have Kiara, Sue, and then Ann. There's only one way to do it. The question really is about the denominator. Okay, let's take a look at this problem. Read it very carefully. It is somewhat tricky. All right, so we have 8 streets which need to be named after 8 different tree types. So there's order here. Because again, if we name the first street ash, that's different than birch. So we're working with permutations right now, right? So the number of different ways we can do this is permutation of 8 pick 8. And a permutation of 8 pick 8 is 40,320. One reason I'm being proactive here because we're going to be talking probability, right? And the denominator is how many ways you can do anything. Well, let's look at event A right now. The event A is the first street is fir, second is pine, and third is maple. How many ways can we do this? Well, there's only one way we can name the first street fir, the second one pine, and the third one maple. There's only one way. But we still have 5 other streets that have to be named, right? and that's a permutation of 5 pick 5. 1 times 5 pick 5 is 120. So A is 120 divided by how many ways you can do anything. 120 over 40,320. Now let's consider event B. Now event B, the first 3 streets are birch, cedar, and spruce, and we do not care what order they come in. So if the first 3 streets are birch, cedar, and spruce, which way, there is P of 3 pick 3 ways of doing that, right? That's how many ways we can do that. And again, the thing is, we're counting here in terms of permutations. Well, we still have the other 5 streets that have to be named, right? From the remaining 5. So the first 3 pick 3, 6, 120, and we get 12, 720 ways. So 720 divided by 40,320. You're probably going to have to think about event B a little bit, because again, this is how many ways we can name the first 3 streets, either birch, cedar, or spruce, right? But again, we don't care which one ends up where, but this is the number of ways, along with the 5 pick 5 ways of naming the remaining streets. So this is the total number of ways we can name the first streets, birch, cedar, and spruce, without concern with the order in which we assign them. So there's that one. Okay, let's look at this particular problem. We're at a car show. There are 10 cars, 12 trucks, and we're entering into a competition where 5 vehicles are going to be selected for the finals. We want to determine the following probability. The probability that we pick 5 cars. The probability we pick 5 cars is the number of ways we can pick 5 cars. Well, if we're going to pick 5 cars, they're coming from 10. We do not care about the order, right? They're all going to the finals. And the denominator is the number of ways we can pick 5 vehicles from the 22 vehicles, because again, that's what we're doing. We're picking 5 vehicles from 22. We didn't say they had to be cars. We didn't say how many had to be trucks. We're asking the probability that when we do select, they turn out to be 5 cars. Well, definition of probability, how many ways we can pick 5 cars from 10, how many ways we can pick 5 from 22 in total. I'm going to leave this for you to do in terms of the math. The next one, the probability that 2 are cars and 3 are trucks. Well, how many ways can we pick 2 cars? Well, we need to pick 2 cars from 10, right? We need to pick the 3 trucks from the 12 trucks. So that's the number of ways we can pick 2 cars and 3 trucks. Pick the 2 cars, pick the 3 trucks. We're not with any order here because we're just selecting finalists, right? It doesn't matter if you're first and third because you're a finalist. The denominator, again, we just need to pick 5 vehicles from the 22. You do the math, you get the answer. Again, this is just a button on your calculator, right? Got it. And I think that is it.